Hello, about mathematical languages and symbols. Matanong ko nga kayo ulit, what is chapter 1 all about? Yes, as a summary, mathematics conveys us that it is an essential tool in understanding nature. So, let's explore more about mathematics in the modern world in this chapter. So, let's proceed. So, again, this is all about chapter 2. Now, the objectives of this chapter 2, mathematical language and symbols, the students are able to classify group of words or symbols as mathematical expressions or mathematical sentences and identify the words in mathematical sentences. According to Shero, one very important element in a student's mathematical success is his competence to communicate mathematically. Herman Well contributes that just as everybody must strive to learn language and writing before he can use them freely for expression of his thoughts, here to there is only one way to escape the weight of formulas. It is to acquire such power over the tool that, unhampered by formal technique, one can turn to the true problems. Language is a necessary tool in the communication process. Good communication requires understanding. Everyone needs to firstly understand the language used in communicating to successfully transmit ideas from one to another. Consider this hypothetical situation. Imagine the following scenario. You're in a math class. An instructor passes a piece of paper to each student. It is announced that the paper contains study strategies for students of mathematics and that you are to read it and make comments. Upon glancing at the paper, however, you observe that it is written in a foreign language that you do not understand. Is the instructor being fair? Will the student be able to receive the ideas being transmitted by the instructor? Definitely, the answer to these questions is a big no. The instructor is probably trying to make a point. Although the ideas in the paragraph may be simple, there is no access to the ideas without a knowledge of the language in which the ideas are expressed. This situation has a very strong analogy in mathematics. People frequently have trouble understanding mathematical ideas, not necessarily because the ideas are difficult, but because they are being presented in a foreign language, the language of mathematics. Now, with the characteristics of mathematics language, like any other language, mathematical language also has unique characteristics that help mathematicians to easily convey the thoughts or ideas they want to express. These characteristics also help every individual to communicate mathematically without the fear of being misinterpreted. Some important characteristics of mathematical language are as follows. First, it is precise. It enables shared ideas, thoughts to be interpreted accurately with very fine distinctions. It prevents ambiguous interpretation of the transmitted ideas or thought. So again, it is precise because it can be stated clearly. Another one that it is concise. It enables ideas or thoughts to be expressed completely and briefly. Another one, it is powerful. It enables to one express complete thoughts with relative case. Again, it is powerful because it is capable of expressing complex ideas into simpler forms. Another characteristic of mathematics language is that it is devoid of emotional content. Unlike other languages, it doesn't give importance to associating emotions or feelings in expressing thoughts or ideas. In communicating mathematically, sender doesn't need emotions to successfully transmit ideas to its receiver. Now, the last characteristic of mathematics language that it is non-temporal. It emphasizes that there is no past, present, or future time in the process of mathematical communication. Everything is in its form, meaning the mathematics language has no tenses, which makes it so unique as compared to other languages. It is important to keep in mind that the language of mathematics can easily be learned, but it requires the efforts needed to learn any foreign language. To proceed, mathematics also has parts of speech. Just like any ordinary language, mathematics also has syntax and structure, which can be categorized into five forms. First, numbers are the very first symbols that can be used to represent quantity. These are nouns or objects in the English language. Second, we have this operation symbols like this plus sign and division sign, or sometimes called as obilos. Then we also have this logical and or wedge, and logical or V. They can act as connectives in a mathematical sentence. Third, we have this relation symbols such as equality sign. Then we have this inequality greater than or equal to, and similar symbol are used for comparison and act as verbs in the mathematical language. We also have these grouping symbols such as this parentheses, braces, and brackets used to associate group of numbers and operators. Then we also have this last category of this parts of speech. We have variables are letters that represent quantities and act as pronouns. Moving on, in the English language, a part of speech necessary in constructing an idea expressing a complete thought is the noun, and any idea that expresses complete thought is called sentence. In mathematics, we also have nouns and sentences. Expressions are the mathematical version of noun. In mathematics, it is also defined as a name given to a mathematical object or interest. This, however, does not state a complete thought. On the other hand, the mathematical version of sentences is called sentences, and this express facts or opinions that gives complete thought. Now, for illustration, we will try to compare the nouns and sentences in mathematical language to that in English language. See the following table. We have English. Consider the following nouns. We have Lisa, Blackpink, Marawi City, and birthday. And in mathematics, we have the following nouns. We have 5, 2 plus 3, 1 half, and x minus 1. And then, going back to English, we have the following sentences. We have Lisa is a member of the K-pop girl group Blackpink. And the capital of the Philippines is Marawi City. And then we have Janie invites Rose to her birthday tomorrow. And then in the mathematics, we have the following sentences. We have 2 plus 3 is equal to 5. And then we have 5 minus 2 equals 4 times x. And then you have negative 1 is equal to 0. Now it can be observed from this table that all sentences numbered 1 are true sentences, whereas those sentences numbered 2 are false. The third examples are sentences that state an opinion, which is either true or false. It is true that Jenny invites Rose to her birthday party tomorrow if Jenny really does. But if she doesn't, then that sentence is false. Similarly, x minus 1 is equal to 0 is true when x equals 1. However, this is false when x is not equal to 1. This simply means that sentences are ideas that can either be true or false, but not both. Similarly, in mathematics, we also have synonyms and antonyms. Expressions that can be expressed differently are called synonyms. Examples of this are the following. First, the expression 8 can also be expressed as 5 plus 3, or you can have 16 over 2 or 16 divided by 2. You also have 2 to the power 3. And we also have quantity 10 minus 3, quantity plus 1. And we also have 2 plus 2 plus 2 plus 2. And we have 4 times 2 and so on. To proceed, the expression 5 times 2 can also be expressed as 2 times 5. Or you can have 1 times 2 times 5 and so on. Antonyms in mathematics exist and are called inverses. These are two different types, the additive inverse and the multiplicative inverse. Note, every real number always has an additive and multiplicative inverse. Now take a look at this following examples for the antonyms. First, the real number 8 has an additive inverse which is negative 8, and the multiplicative inverse is 1 over 8. And then second, the additive inverse of the expression negative 3 over 7 is positive 3 over 7, while its multiplicative inverse is negative 7 over 3. We denote the additive inverse of any real number a as negative a and its multiplicative inverse by a to the negative 1. Multiplicative inverses are commonly known as reciprocals. Languages have conventions. In English, for example, it is conventional to capitalize proper names like Anna and Japan. This convention makes it easy for a reader to distinguish between a common noun like Carol, a Christmas song, and a proper noun like Carol, a person. Mathematics also has its conventions, which help readers to distinguish between different types of mathematical expressions. Mathematical conventions are defined as sets of facts, names, notations, which are widely used in the area of mathematics. Mathematicians abide by conventions in order to allow readers to understand what they write without constantly redefining basic terms. For instance, the fact that one evaluates multiplication before addition in the expression 2 plus 3 times 4 is merely conventional, since PEMDAS is mathematical convention. Another one is letter conventions. In mathematics, letters often have special uses. For example, letters at the beginning of the English alphabet, such as A, B, and C, usually mean constant or fixed values. In the general equation y equals ax plus b, people may assume that a and b are fixed value, and x is the one that changes, which in turn makes y change. Aside from that, letters from I to N, that is I, J, K, L, M, N, usually mean positive integers, and letters at the end of the English alphabet, that is X, Y, Z, usually mean variables or unknowns. Note that letter conventions are not rules, but they are often used as such in the world of mathematics. Now, you have to watch this video at your convenient time. This video is about Math Isn't Hard. It's a Language by Randy Palisuk. You can have this link for you to watch the video from the YouTube. Now, for your activity, you have to write a one-page essay about what you have learned after watching the said video. So here are the references that I use in this chapter 2. Hello again. Thank you for watching the video lecture. You are actually expected to use mathematical language appropriately in speaking and writing mathematical ideas. Let's continue praying that everything will go back to normal so that we can have this face-to-face learning. I hope to see you in campus. Carpe diem.